Hey everybody, and welcome to the top of Saddle Rock, which overlooks Wenatchee. Yeah, it's warm today. I'm here with some students. We're going to have a discussion after huffing and puffing more than 1,000 feet of up to get here to the top of Saddle Rock. So let's flip you around and have you join us. Hey, 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 Sion, hello. Oh, a perfect profile against the sky, and Daniel made it up, huh? Okay. All right, get your breath. Thanks for joining us. Catherine, how you feeling?
Alive.
Okay.
I was questioning my sanity and will to live a little bit in the very beginning, but it was worth it.
It was worth it, yeah. Look at this. Yeah.
We have sunscreen?
God.
Mango flavored?
Yeah. Okay, well, let's just kind of give our viewers a sense of what this is, and then we'll just have a little discussion, you guys. So, this is a Geology 351 class, and we are overlooking Wenatchee. Right now, you are looking east, and the wind, of course, has just picked up. We can roll with it. And Catherine's on mic right now, but I think I'm just going to share the mic and just kind of get around here a little bit. So Catherine, you don't have to talk the whole time. Davey, let's get us started, please. We're thinking about the bedrock first of all. So your thoughts about the bedrock here of Saddle Rock. You have no idea. We were looking as we were hiking up. Your early thoughts about what kind of rock is here.
Well, it's not dark enough to be basalt, and looking at that piece over there, there's not big enough crystals to be in, I think it's intrusive rock.
Okay.
So it's gotta it had to have cooled on the surface, and it's not red like rhyolite, so I'm gonna guess it's gonna be like dacite or something.
Out here, Josh.
Something.
Some sort of something.
Yeah.
Any observations that you can make?
It's very fine grain.
Fine grained.
It's
Kind of
about it.
rotten looking,
Can't
right?
really see much.
Yeah. I'll follow you guys. Let's go over to where Josh was and see if we can get any kind of up close and personal observations of that rock over there and see if we have anything meaningful to say. And it's a rotten looking rock. It's not going to be easy to identify, for sure. But we're maybe even just trying to decide if it's igneous or sedimentary or metamorphic or volcanic or plutonic. Anything? This is rhyolite. And it's very difficult to tell that it's rhyolite because it's been altered. So rhyolite normally is a pink or a maroon, and there's hints of that here and there.
Right down there?
Down here, yeah. Yeah, maybe this is our best look. Yeah, if you want to see some good rhyolite, this is probably the best spot right in here. I don't know why it's less altered right in here.
Maybe just in the gully right there.
Yeah. Yeah, we can see some little phenocrysts. But most of this stuff is so bleached out. It's like, what in the world? So, there's a guy named Jeff Tepper at the University of Puget Sound. And he was, with his seniors, going around eastern Washington collecting igneous rocks and doing detailed chemistry and getting some detailed ages on them. And he was finding a pattern of some of these igneous rocks, both granites and volcanics, up in northeastern Washington that were about 52 million years old. And then they started to get younger and younger and younger as you went southwest towards Wenatchee. And so I happened to catch him at a poster presentation 3 years ago, right before the pandemic, and I said, "You still doing this sampling business? You want any more sites for your potential pattern?" He's like, "Yeah, I'm looking for a few more." I said, "Have you ever been to Saddle Rock in Wenatchee?" He's like, "No." I'm like, "Well, why don't you come over?" Of course, then the pandemic happened, so we're doing a little covert, operation out here, in the fresh air. But he sampled here, and he sampled at Castle Rock, which is just off the way, and he ran the samples, and they're 44 million years old. And the chemistry and the age and the location says that this is the very end of some sort of Farallon plate rollback story. So in other words, his 52 to 44 million year age progression includes this spot right here. But he's also done some stuff closer to the Cascades, and he's clear that the Cascade volcanic arc started about 44 million years ago. So this is like the last gasp of this weird age progression, which leads us to the question, what kind of volcano should we visualize here? If we know this is rhyolite, and yes, Davey, this is rhyodacite. So there's true high silica rocks, rhyolite, and some rhyodacite, which is slightly less silica rich, but still pretty damn sticky. What are some possibilities? Cyan, you want to come up with something? What kind of volcano can we imagine if this is rhyolite here? I know you're a fossil guy, but like...
Yeah. Very explosive eruptions.
For sure, for sure.
I don't remember what that's called.
Okay.
I don't remember what that...
Well, let's think back to 101. Like, what volcano choices do we have at the 101 level? Catherine, you got the mic.
Stratovolcano.
Okay, so what kind of lava is typically there?
More of a like the kind that produces from the stratovolcano.
Mm-hmm.
Heavier and felsic.
Yeah, typically, but yeah, about anything can happen with a stratovolcano, right? But these plugs, maybe while we're still chatting, I can point out a couple more. Each of these plugs are rhyolite, and each of these plugs that have been dated so far are 44 million years old. So it's like there's kind of a, right in here in the Wenatchee area, kind of a regional igneous story, very high silica magmas, making these little pinnacles here and there. So I don't know if we should think of a stratovolcano.
Is it caldera?
It might be a caldera or some kind of rhyolite dome or rhyolite plug or something a little bit more tied to the Yellowstone scene. So do we have enough of this material to actually map out a caldera? No, we do not. But there's enough of these plugs to say this is probably not a Mount Rainier-like volcano story. First of all, we're way too far east for that, right? We're off trend to the Cascades, and we're also just barely too old. But to tell the story about why there's all this high silica magma here in Wenatchee, we got to think seriously about this 44 million year time frame. And if we're back in this Eocene, and that's what we are, yeah, we're talking about supervolcanoes that dominated here in central Washington, which is an emerging story. Right over there is an old gold mine, the Cannon Gold Mine. And that gold is associated with these rhyolites. The Wenatchee Dome itself is also 44 million years old. So some of you know there's some gold just north of Ellensburg in Liberty. That's the Teanaway Formation. That's slightly older, but that's also bimodal. That's also rhyolites and basalts. So nobody has made a convincing case to tie the gold of Wenatchee with the gold of Liberty, which is just basically 20 miles over the hill. There has to be a connection, but nobody's made it yet. All right, I meant for this to be a discussion, and instead it's turning out to be a retarded lecture. Let's try to do something with the Ice Age floods where everybody can participate. Would you mind coming over here, please? Let's go back to our first spot. Without wiping out, he says to himself.
I'm gonna wipe out.
I should have gone down that way. Josh with his hands in his pockets. No big deal. No big deal. The old Tri-Cities balance kicks in. Catherine, what do you know about Ice Age floods in this stretch of the Columbia River? Did Ice Age floods ever come down this river?
Down the Columbia River, yes.
Yeah. Any sense of scale? How deep was the water here?
Just about 200 feet below where we are now.
We were just talking about that. So yeah. So Richard Waite from the USGS has mapped out a major flood bar that's underneath East Wenatchee. So again, you're looking at Wenatchee proper, and then East Wenatchee across the way. And on the other side of the river, there's a pile of boulders and rocks that are about 600 feet high. And he has worked with maps where they have found ice rafted erratics up to a certain elevation, much higher than the top of Pangbourne Bar. So our calculations from Richard's work is that, what'd you say, Davey? Elevation of the river, 930 feet above sea level?
So it's 730.
730 above sea level, and elevation of us up here, 1990, 1,990 feet above sea level. Forgive us if that's off. We're just doing this with our phones. So we're trying to visualize the high water mark of the biggest Ice Age flood, whenever that was, coming down the Wenatchee, and it's coming down from the north. It's filling this broad valley, more than 1,000 feet of water, according to the volume of the deposits, according to the high water mark of the ice rafted erratics, and then that water is eventually draining to the south. Now the entrance to Moses Coulee's down there, Vantage is down there, and so this is a big basin. We're going to drop a lot of rocks in this area, but to have the high water mark of the biggest Ice Age flood getting within 200 or 300 feet of the top of Saddle Rock, that is a jaw dropper. What kind of deposits do you imagine down there, you guys, if it's a big energetic flood?
Coarse grains.
Coarse grained. How coarse is coarse?
Pretty coarse and angular.
Yeah, we might have boulders that are 5 feet, 6 feet, 10 feet across, and we do in some of those neighborhoods of East Wenatchee. That's the size of some of these boulders. And there's plenty of sand as well. Oh, I can't hold it. So I've been playing with the idea in class that what if the major floods, what if the huge monster floods are from an older chapter and not a younger chapter? And what if the monster floods coming down over Wenatchee are not from Montana? What if the monster floods of water are coming directly down the Okanagan from the ice sheet in Canada, a la Jerome Lessman? We're just playing with those ideas. How old is old from our discussions?
Over 100,000?
Oh, yes. In class, I tried to just play it safe and say our older events, our older floods, if we're really starting to think carefully about them, and I think we are, is older than 100,000 years ago. And some of you who are watching the program right now might go, well, that sounds way too old for what I know about the Ice Age floods. What's the younger flood, Jasmine? What's the dates on the younger flood stuff we normally have here?
About 70.
I think even younger than that. Anybody else, Catherine?
13 to 20.
Yeah, younger than 20,000 years ago is the conventional story. And many of the workers who've worked in the Wenatchee Valley are saying that everything's happening younger than 20,000. I'm just starting to wonder if that's right. I mean, we definitely have some dates regionally that are younger than 20,000 years ago, but who's to say that this incredible Pangbourne flood bar is that young? Or if there are some dates from the very top of Pangbourne, who's to say that's maybe just from a thin top, and maybe the guts of the Pangbourne are much, much older. In other words, those watermelons and bigger were dropped in there much earlier. Who's got things they notice from up here that you're curious about? Doesn't have to fit into the two narratives we've just got. Daniel, you got anything? You got some water in you now. You got everything going. Anything in this 360-degree view you're curious about?
Well, right off the top of my head, I'm just noticing that everything out in front of us is a whole lot flatter than everything behind us.
That's true. That's true. So it's flatter out in front of us. Are you talking all the way to the top or just kind of down there by the river?
Just everything up to the top, it's a whole lot smoother.
It is, yes. So good observation. So we're looking east across the Columbia River and East Wenatchee and beyond. There's kind of a, I don't know, almost a gradual ascent. And then Daniel's noticing that the topography is very, very different as we look back to the west towards Ellensburg. Anybody got an idea why that might be? Sion.
Well, that's all. I may have my dates a little bit wrong on this, but that's all accretionary terrain, and it is all coming this way. So there's a bit more squishing happening in this direction that could be uplifting this a bit more than that side.
Okay, I like it. You're right that the North Cascades extend this far down south towards Mount Stewart. However, up there in the snow is Mission Ridge, and that's Columbia River basalt. So our old buddies that we saw at Drumheller and Frenchman and everything else, you can draw a line between the green in the foreground and the snow in the distance, and Ellensburg's right over that ridge, by the way. So we're at a very important boundary, Columbia River basalts, and if we swing our eyes to the east and continue way south to where we lose the Columbia, on that ridge across the way that Daniel's pointing out, that's still the Columbia River basalt. So there's just kind of a big black Sharpie line saying to the southwest to east, that's all CRB, flood basalts. And so the exotic terrains are a little bit further beyond that. Daniel, I have an answer for you if you're curious why it's more, that topography is different over there. There's landslides that have been mapped. So the idea is that basalt used to be maybe over Wenatchee, or at least closer to Wenatchee, but there's been periodic landslides of basalt material just slumping towards the river. And the result is that kind of hummocky lowland that we can just kind of barely see in the haze. Speaking of landslides, one of the biggest landslides, maybe the biggest landslide in the state, started up towards the top there. And again, edge of the basalt, that's not an accident, I don't think. And there was a huge landslide that went, how can I describe it? You won't have a great view of it, but all the land between the high snowy ridge and the forested ridge below it, there's a big hole. Can you see between the snow on the horizon and then this next ridge closer to us? That's a big open area, and that's open because there was a huge Malaga slide where the stuff just slid towards the river and blocked the river. And the Rock Island Dam is down there where that Malaga slide dumped into the river, perhaps about 19,000 years ago, but that's also not a very great date.
Damn.
So there's big landslides on both sides of the river, but this one's a doozy on the other side. Thanks for coming through on that, Daniel. Who hasn't spoken? Anthony, you're a guest today.
Uh-oh.
Love to hear it. You have any observations or questions about what you can see up there? It could just be like, where's the Fred Meyer? And we can point that out for you.
There you go. The only observation I see is just kind of the sandwiching of the rock, and it seems like it goes at a 45-degree angle up in that way.
Thank you. Yeah, there are some fractures that do kind of, if you squint, look like there's kind of a 45-degree angle. I agree with you there. And perhaps that is consistent through these pinnacles here. I'm not sure, though. And now I see that rooster comb from here. Davey, you wanted your maroon or your red for the rhyolite. We've got it now, baby. So that rooster comb is also rhyolite. I mean, I don't know why we lost the maroon here on saddle. Just more alteration, hot fluids bringing the gold and silver perhaps. And then the entrance to these underground gold mine tunnels is at Wenatchee Dome, also dated at 44 million years ago by a student named Gilmore at the University of Washington.
So up the valley there, it's more narrow here, and as soon as you get into Wenatchee, it really opens up, and then it's probably big here and goes back down over there.
That's big. Thank you. Good observation. Yes, Josh is reporting, I think you heard him, that pretty narrow Columbia Valley in the haze coming at us. Pretty narrow Columbia River Valley to the south going around the corner. Why? I think there's a couple of reasons. One, the rock is pretty hard up there. That is where the Swakane gneiss is, and that's difficult stuff to chew through. So the river's had a hell of a time getting through it down there. That's where the river is trying to deal with the Columbia. Okay. All right. You want a cool thought? Here's a cool thought. Once upon a time, everybody, the Columbia River used to flow from northeastern Washington and diagonally right down towards Josh's house at Tri-Cities. So in other words, before 17 million years ago, we have decent evidence that the Columbia River used to be just kind of a straight river from north of Spokane to Tri-Cities. And then what happened started 17 million years ago?
The salt just started pushing it.
You got it, Scion. The flood basalts started erupting out of cracks down in Oregon first, and then some of the cracks were in southeastern Washington, and the lavas started flowing towards us, and guess who got pushed off of its linear course? The frickin' Columbia River. And here it is still, to this day. This river has been on the edge of the Columbia River basalt lavas for 17 million years, and it's still stuck in this gutter. And so, yeah, if we look north, we got flood basalts on the right, 17 million years old, super old crystalline rocks of the North Cascades to the left. Down here, the river cuts through the basalt, but, and here's the big point, we think originally, 17 million years ago, when this Columbia River was pushed to here, it was truly pushed to the edge of the flood basalts everywhere. So who's feeling like they want to think quickly on their feet? That's basalt, 17 million years old. How far in that direction can we find the flood basalt? Is there flood basalt in Ellensburg? Yes, there is. Menashtash, that's flood basalt. Lyons Rock, north of Ellensburg, that's flood basalt. Is there any place further west yet? I don't expect you to know this, I guess. There's a place above Cle Elum called Lookout Mountain. And that's the end of the line for the Columbia River basalt lavas. So what am I saying? This river used to flow to Cle Elum. It just stayed around the edge of the German chocolate cake. And then at some point, it decided, well, I'm not going to keep going to Cle Elum. I'm going to work my way back towards the center because maybe there's been some crustal sinking due to the weight of the lavas, due to the weight of the cake. And so this river decided to cut through the cake here. But it's narrow, Josh. I take your point because it's trying to get through the German chocolate cake here, just like it's trying to navigate that hard rock over there. That was fun. Didn't expect that. Okay. Anybody else?
I just love that the Columbia River is like 40 million years old. Maybe older.
You just like that the Columbia River is so old. You came up with 40. Do you have any? I've never heard that.
There's a cross-cutting relationship over the Cascade Mountains.
Oh, yeah.
Like it cuts through them because it was there when the Cascades were being built.
You're right. You're right. Cool.
I love it. I really like old rivers. Alright, sounds good.
Okay, we'll see you guys down there.
Yep.
It's a very pleasant group. We have 22 in the class, but they're very busy this quarter between Geology Club and the Association of Engineering Geology, and a summer field class where they're doing exercises outside of the school day. So I'm making these 351 trips optional on Thursdays, so about half the class shows up. And a few of them never miss. And we just keep thinking about floods. We keep thinking about many of the themes that we've been working on this quarter. So this place called Saddle Rock is very accessible, big parking lot, popular trails, and if you haven't been over to Wenatchee, Washington to experience this, it's waiting for you. See you guys down there.